All right, we're going to go on to section 7.19, linear and nonlinear patterns of change. It's the last section in chapter 7, which is pretty exciting. And it's actually not too bad. There's just kind of one rule that we're going to be talking about. We've been talking about two different kinds of graphs. We have these linear graphs and nonlinear. And what you should really hear when you see linear is a line. So you can think of this as not a line. And for example, if I drew some quick examples of what some linear graphs might look like, let's see. Let's do 1, 2, and 3. This one might look like this, and it might have a line that kind of goes through our we have our x and our y axis, and it kind of looks like this. I should use another color for the line part. I could have another one that looks like this. It can be going down as well. Doesn't matter the direction that we go in, x and y. And I can also have a flat line if I want that kind of goes this direction as a line as well. And these are all linear because if I lined up my ruler, I can get a rule that's very easy to calculate for these. However, I can also have nonlinear equations. And let's label my axes, x and y. And a lot of times we can just tell by the shape of these. For example, they can look like this. That could be one. We can put our little lines on it like this. And sometimes they can even get a little crazy and they can kind of go up, down, and then back up again like that. And we can tell these are nonlinear because they do not follow a solid line. I could not put a ruler on this, but I can still come up with a rule that gives all of these x and y directions. In fact, as long as the number is a function, which means it goes through and it passes this pen test where I can write the whole thing without lifting up my pen, I can create a rule to make any possible shape that I can think of as long as it's a function. What we're going to be doing in this section is determining whether things are linear or nonlinear, but only looking at the t-chart. If you recall, the t-chart, I hope I called it that before, is that symbol that kind of looks like this. And it gives us, we can usually do our x and our y, and we can write our inputs and our outputs. Okay, I'm going to make a quick t-chart, and then we're going to talk about whether it's linear or nonlinear. Let's see. Let's do 3. All right, so what I could do on this is I could build my little graph and graph it out. And once it's graphed, it's really easy to tell if it's linear or nonlinear. But our goal is to find an easier way. And the rule that we can use for these is for it to be linear, every time this goes up 1, the y must go up the same amount. So if I could write this as our rule, for every change, the change and y must stay constant. Okay, so what I can kind of do is I can notice that, well, here, from here to here, it changed 1. And I can even write my little triangle, which is a Greek delta, which means change of 1. And I can see over here that there was a change of 2, okay? From here to here, there was a change of 1. Here there was a change of 2. Okay, looking good. Change of 1, change of 2, change of 1, and change of 2. Okay, that means that this does follow my linear rule, and this section is linear from this t-graph. And I didn't even have to graph it. I could look at the rule from here. Okay, let's look at another one. I'm out of space. If you have space, awesome. You probably wrote more efficiently than I did. Let's take a look at another t-chart. X and Y. Okay, I have 1, 2, 3, 4, 5. And here I have 3, 6, 8, 15, 8. Okay, you might notice already what's going on, but we're going to map our changes anyway. Okay, here we have a change of 1. Here we have a change of 3. Okay. Here we have a change of 1. Here we have a change of 2. Oh, this is already a big clue. This is probably not going to go. So even if I have one number that's out of whack, that means I have to be nonlinear. I am going to go through the rest of these, though, just for practice on this one. Change of 1 again. This time I have a change of 7. Change of 1. And this time I have a change of negative 7. Okay, so this is definitely non-linear. If I graphed this, it would probably look something like, kind of like that. And that means it would kind of go on in those directions. Let's take a look at one quick last one. And there's something here I want to show you that can also happen. We might get our x's, they might not be so nice with 1, 2, 3, 4, 5s. We might have it as like 0, 2, 4, 8. Okay? This one, it might be something like 10, 20, 30, 50. Okay, we're going to do the same thing that we have here. This time I have a change of 2. This time I have a change of 10. Now, what I really am more interested in is my slope, or my unit rate. So I can say here that, well, this one up 2 and this one up 10, so that every one, I should have a change of 1 should be equal to a change of 5 in my y direction, because there's a difference between 2 here. So I want to make sure that all of these kind of follow that same thing. A change of 2 is a change of 10. Okay, that works out. And a change of 4 is a change of 20. Okay, so now that I have a change of 4 and a change of 20, is that the same as a change of 2 and a change of 10? Well, yes it is, because if I wrote this as a fraction, 2 over 10, I could set that as equal to 4 over 20. And in fact, those two changes are the same, because I can simplify both into 1/5, and I can tell that yes, they're the same, so I know this to be linear because the change in all of them is the same. For every x spot we move up, we move the same number in the y. Oops, I forgot to label my axes in this case. I hope that makes sense. If you get it, go ahead and go on. If you're not still sure, I'm going to do number 1 on here. So I recommend trying it first and then seeing if you agree with me. All right, our little t-chart, x and y, we have 0, 1, 2, 3, 4. And our y's, we have 2, 3, 5, 4. Oops, 2, 3, 5, 4. Oops, I don't have a 3, I see. 2, 3, 5, 4. Okay, I'm going to do the same thing I did before. let's take a look at some changes. Okay, I have a 1, I have a 1, I have a 1, and I have a 2. Oh, that's a big change, and that looks likely that we're going to be nonlinear. But I'm going to do the rest just in case. Here, from 2 to 4, I have 2, and then from 5 to 4, I have -1. Well, that is definitely not going to work because I was going up and now I'm going down, and I can tell this is definitely going to be non-linear. All right, hopefully that makes sense. If it still doesn't, find a friend or an adult and ask them for some help. Good luck.